Thank you, everyone. Good afternoon and welcome to our Proteus launch event. I'm Suzanne Armstrong, Executive Director at World Discoveries, and will be your host today. Before we start, I just want to give you some few Zoom-related housekeeping notes. As you've noticed that you do not have, as participants, you don't have the ability to unmute or have the video on. This is for security purposes. We've kept that, but bear in mind that as soon as we get into the breakout rooms, that's going to be lifted. So you'll be able to unmute yourself when we are in the breakout rooms. In the meantime, if you have any questions, please use the chat function and text your questions or comments, and we'll address them accordingly. So with that, I think, as you know, as I said, when we move into breakout rooms, you will be able to navigate between the rooms. Please make sure that you have your latest Zoom setting set up, so you will be able to move between the rooms at that time. So next slide, please. So I'd like to start our event with the land acknowledgement. Recognizing that this is a virtual event and we have attendees from a large range of locations, the land acknowledgement I am giving today is representative of the land I'm located on in London, Ontario. I invite each of you to respectively reflect and acknowledge the land that you're located on today. I acknowledge that Western University is located on the traditional territories of Anishinaabe, Haudenosaunee, Lenape, and Chinookan nations on lands connected with the London Township and Soundbra Treaties of 1796 and the Dish with One Spoon Covenant Wampum. This land continues to be home to diverse Indigenous peoples, whom we recognize as contemporary stewards of the land and vital contributors to our society. We're gathered today to launch the 8th year of this competition alongside of our founding partners, Tech Alliance, Western Research Park, and Western Moorset Institute for Entrepreneurship. Our competition partners include Ontario universities such as University of Guelph, McMaster, Windsor, and University of Waterloo. I'd like to thank our collaborators and partners who've been working with us to bring this year's competition to our innovative and entrepreneurial communities. And a big shout out to our sponsors whose financial contributions to the event provide the prize for the winners of the competition. This year's silver sponsor is Gowlings, and our bronze sponsors are Explore IP, Life Sciences Ontario, and Gordon Lang School of Business and Economics. At this point, I would like to invite Christina Fox, CEO of Tech Alliance, for opening remarks. Christina?
Thank you, Suzanne, for the kind introduction. Tech Alliance is the place for dreamers, innovators, and world-changing ideas. So good afternoon, everyone. I'm Christina Fox, the CEO at Tech Alliance, and I'm really thrilled to be joining all of you this afternoon. As the innovation hub for Southwestern Ontario, we empower world-class ventures and fuel growth in Canada's innovation economy. And we champion and coach entrepreneurs and amplify businesses while creating a vibrant technology community in this region. And as a founding partner of Proteus Innovation Competition with World Discoveries and Western, we aim to grow and strengthen the collaborative experiences between academics and commerce, research and businesses, institutions and community. So continuing to build on the momentum as a vital resource for industry leaders, tech talent, and technology innovators like yourself, our team knows that innovation brings really exceptional people together. And this year, Proteus is already shaping up to reflect that. So I wish the very best of luck to all the competitors throughout the experience of Proteus, and please do enjoy the competition end to end. Back to you, Suzanne.
Thank you very much, Christina. At this point, I think I would like to actually introduce our keynote speaker, Chris Leclerc. Chris is the manager of Venture Studio program at Accelerator Center in Waterloo. He joined the Accelerator Center after finishing a master's degree in biomedical engineering in stem cell and regenerative medicine space at Western University. During his graduate degree, Chris participated in a variety of opportunities offered by World Discoveries, such as the Graduate Innovation Scholar Program and Proteus Innovation Competition to expand his knowledge in technology commercialization. Leveraging many of the skills he developed in these offerings, Chris chose a career in technology transfer where he joined an established accelerator in Kitchener-Waterloo region. Since joining the accelerator in March of 2020, Chris has led several programs in which he has provided non-dilutive capital to Southern Ontario companies and sourced and source scale-ready medtech and health tech companies for a commercialization project in partnership with Grand River Hospital. With the launch of AC Studio in September, he's very excited to work directly with and provide up to 100,000 to Southern Ontario's up-and-coming technology startups. Chris, it's a pleasure to welcome you back to Proteus, and we really look forward to hearing about your adventures since your time at Western.
Awesome.
Sorry,
Thank you so much.
Oh, you're there, Chris. Okay, sorry. I thought we were on a connection issue. I do apologize. Carry on.
No problem. Thanks so much for having me. London has had a special place in my heart. Obviously, I spent 6 years of my life there. And I remember being in the exact same spot as a lot of the students in the room here. So it's an absolute pleasure to be back and kind of share some of the knowledge that I had going through this competition, but as well as kind of what I've learned through, I guess, the very early days of my career. So I've kind of titled this, starting small and dreaming big. As a student, you don't really know where you're going. You're kind of just very new to everything. You kind of have to figure out an interesting path. And I really think opportunities like this, things that are hosted with World Discoveries, Tech Alliance, as well as some groups from Ivy as well, are really great opportunities to kind of expand and develop your skills beyond what you're learning in your regular courses. So a little bit about me. As Suzanne mentioned, I'm a program and client experience manager at one of Canada's leading accelerators. So we're based in Kitchener-Waterloo. We have 3 locations across the region. We're typically always working with around 200, I would say, startups, depending on how many programs we're running. Typically, I'd like to say my role's generally helping technology startups just by building a business through a variety of different customized and multidisciplinary programming opportunities. Really optimized for companies' growth, that scalability factor. Just for fun, massive fan of coffee, traveling, also an avid scuba diver on the side. You might ask why I'm in Ontario for scuba diving, but there's actually some pretty cool diving here. What I studied during my time at Western, I was a graduate in physiology pharmacology, so I did a biomedical sciences degree for my undergrad, as well doing a biomedical engineering degree for my master's. Always had the dream of doing med school. Unfortunately, it just didn't happen. And just felt maybe it wasn't the right fit for me as an individual. So my master's was really focused in on stem cells and regenerative medicine. I was doing a project with Dr. David Hess Brobart and Dr. Lauren Flynn. So combining more of a physiology with an engineer and trying to do a joint project, something collaborative between the two of them. It was a really, really cool project that involved umbilical cord blood stem cells. We collected it from many, many, many samples down at Vic Hospital, most of the time in the middle of the night trying to collect those. And then also doing a tissue or a biomaterial that was derived from bat tissue, trying to combine them together and treat a clinical disease. Really cool on the surface, but unfortunately, one of the quick things I learned was it was just very, very narrow in scope. It was kind of something that I couldn't really expand. It was just very, very structured. So I came up to kind of the general grad school conundrum, like what was next? What was next for me in my career? Was this something that I wanted to continue on with? Was this something that, I wanted to jump ship into something else? At the time, my entire network was academia, right? I'd done 6 years in school. I knew a bunch of grad students and others doing kind of the academia route. I didn't really know what was beyond. So I had kind of like 3 different paths in what I was considering. I was considering academia. Do I continue on with my PhD with the goal of becoming kind of a tenured professor, starting to look into more of the research side? Do I go into industry and kind of explore a role within a medtech or biotech space for a larger corporation? With that, I found the roles were kind of one-dimensional, and I wasn't able to kind of explore many different roles. Or do I go into a startup, right? Do I commercialize my own research, or do I join another small team and kind of start to commercialize and help build up a technology? So lucky enough, I call it kind of the World Discovery Effect. Can't ignore Tech Alliance as well, because they were obviously collaborating on a lot of these initiatives. So a lot of my courses were all focused in on science and engineering. I never really had any formal training in business or technology commercialization, because you kind of got penalized if you were going to take another degree, you wanted to explore, and you got a bad mark in it. It kind of lowered your overall GPA. So I played it safe. I took kind of science and engineering courses, avoided anything that was just too crazy. And I kind of kicked myself for it. I didn't really have any experience with any of that stuff. So in my grad school, I saw these 2 opportunities. the Graduate Student Innovation Scholar. So any for grad students out there, please take a look at this. There's a small stipend associated with it, but you also get a really cool opportunity to kind of develop a commercialization strategy for real technology that's coming out of Western. And at the time, Suzanne was actually my judge for it, and we got absolutely kicked down on our business plan. It was terrible because it was our first time doing something like that. But it helps you kind of learn. You're kind of learning from the failure, starting to kind of figure out what's best and build up a skill set that's more favorable for a wider range of professional roles. So conveniently, the role I'm in right now kind of combines all three of the different paths. I work a lot with schools, I work a lot with industry and kind of larger corporates. And for the most part, I work with a lot of startups and a lot of founders. So over kind of my time, I started very early on in the pandemic. This was back in March of 2020. I joined at the time right before we went kind of full virtual, but anyways, it hasn't really reduced the impact of it. But I've kind of worked on many different programs, from more community-based stuff for all stuff to acceleration, working with companies that have an idea that's like basically on the back of a napkin, all the way up to companies that are more kind of closer to Series A. I worked with my first company that just IPO'd back in February, I think, of this year, or 2021. It's all a blur. This picture in the background here is actually Martin Basiri from Applyboard. They're a company that came through our startup visa program back in, I think, 2012. Three brothers at the time from Iran. They started their company, came through our startup visa program, as well as our non-dilutive seed funding program. And now their company is valued at over $4 billion. So it was really cool to chat with him. He's gone from three brothers to thousands of employees kind of worldwide. So it just kind of shows you the range and what you can learn from individuals that have grown companies like that. We'll talk a little bit about kind of our organization. I won't talk too much about it. If you're interested in it, just check out our website, acceleratorcenter.com, or connect with me on LinkedIn or email. I'll have some links at the end. Our main focus are kind of more community acceleration and global frontiers, community being very local-faced initiatives that support kind of the local ecosystem and building kind of that community aspect. Acceleration's more short-term focused programs that engage a variety of different government and corporate partners for those very sprint-style, very targeted effect programs. And then we have a variety of different global frontiers programs that help startups go global from day one, connect founders with new markets, as well as emerging funding opportunities. Just to show you, we've been in operation for quite a while. We've been in business since 2006. For our startups, they've raised over 1.8 billion. This is USD. Company portfolio valuation of 5 billion. 750 startups have been supported, and an 85% survival rate across all of our programs. So now that's probably enough about me. I know all of you here are kind of, how do I win this competition and actually get this, potentially win it and get the money at the end of the day. So I'm going to say my opinions. There's many opinions in kind of the entire industry. So kind of take what you hear from me with a grain of salt, figure out what resonates, and kind of move forward with that. This is all the stuff that I've learned from participating in it, as well as through all the startups that I've worked with. And it's very targeted towards the Proteus kind of experience. So tip number one is make it meaningful to you. So really look at the 5 amazing technologies that the World Discoveries team has picked and put in front of you, and pick something that has meaning to you. You know, whether or not it's something that's connected to you or your family or a team member, something like that, or the passion of yours or hobby. There's always some meaning that makes the work a lot easier. So having a shared cause or purpose is motivation to really carry the technology forward. So in my case, when I was back doing it in 2018, at the time, we were working on a monoclonal antibody that helped kind of reduce inflammation after spinal cord injury. So one of my really close family friends, this is Sean, he was in a pretty bad car accident that kind of left them as a quadriplegic a year or two prior to this competition. And it just kind of helped think, you know, like, what if this technology was actually available at the time of his accident, and being able to actually apply that and help support him. So just kind of gives you some motivation and passion to actually continue on with the project and be interested in the research. The second piece is to tell a story. So really take the time to set the scene effectively and end on a crescendo. It's a really good idea to avoid any plot holes in the story, make sure everything's connected well together. And the fact that people really make decisions based on emotion and then look for facts to back them up. So if you're able to kind of elicit some emotion in your audience, both through your business plan as well as through your pitch, it's a really good opportunity to kind of connect with the audience, connect with whoever's reviewing your application, and then use facts and everything and metrics to back it up. Tip number 3, understand the problem. So this is a really, really big one. Don't start with the solution. Start to think about who has the problem, what is the problem, and why is the timing right for the solution, right? I've worked with a startup that had basically designed the AirTag. He had designed it 10 years ago, way back in time, and couldn't find anybody to buy this thing because the smartphone technology just hadn't caught up to this technology. So he ended up abandoning it and then just continuing on with a different venture. But you look at all the different technologies that have kind of become something in that space and how much they're worth. And it's really important to be as specific and quantitative as possible with this data to back up kind of some of the emotional and metrics there as well. Understand customer relationships. This is a really big thing not to ignore. So when you look at your technology, your product, there's going to be a different value matrix for who you're providing value to. And you have to really understand on who you're specifically targeting, both within your outbound and inbound channels, but also leveraging some of the different internal relationships that kind of push your business forward. So there's the buyer. These are the decision makers involved in the buying process. They're typically C-level or executive leadership that are going to be the people that are going to be signing off on your purchase. You also have the users, who are the people that are going to be using your product. So people very involved with the use. You kind of have to optimize your user experience for them, but they won't be really important on the buying decision. And then you have individuals that who will both purchase and use your product. So this might be different for the 5 different technologies. Just make sure you consider that. And then there are also sometimes a second layer of their customers, right? So who are you selling to? Who are their users? And then who's actually going to be benefiting from this technology? So you can kind of look at a value axis that way. Understand your value proposition. So what are the goals and need of your customers? What pains are they experiencing? And how does your technology either reduce these pains or create value for their experience? So this is something you should be very clearly able to articulate because this will kind of be the main focal point of what you're pitching in both your business plan as well as your pitch. So this is something that will be delivered, this benefit that will be delivered to your customer, and how their life will quantitatively change in response to this technology. You can see cost saving benefits, you can see potential increases in revenue. You got to kind of understand that return on investment of your customer and kind of how your technology plays into that. Note that this value proposition may be different for some of the different customer groups that I said earlier. As higher level executives will want to see kind of changes in their bottom line, whereas the users and stuff will want to see the value in their general workflow as well as how much impact they're making for their customers. Not all the time, but there's some differences there. Understand your market. So create FOMO. We've kind of seen it with the rise and fall of a variety of different markets. You really want to be kind of chasing and looking at those new and exciting markets to kind of apply different technologies. Use both top-down and bottom-up approaches to understand your total addressable market, your serviceable available market, and serviceable obtainable market. If you don't understand what any of those are, have a look what they are. They'll definitely help you kind of identify who you're targeting within your market. Review international markets. That's a big thing. We're a relatively small country, so globalization is something we really have to take advantage of. And there's a variety of different international markets that may have more forgiving regulatory pathways, more interesting geopolitical avenues that are kind of happening that will help you kind of access that market a little bit easier before you might target something that has a larger regulatory hurdle, like the Canadian and US markets for typically med tech and biotech and whatnot. And always think about growth. What kind of markets are you targeting? How are they growing? And then I have 2 more tips. I know I've gone a little bit over time, unfortunately. How do you plan to sell into your markets? Is this something that you're going to be using direct or indirect sales? Are you going to be using a distributor? What's your sales and marketing strategy? How are you going to kind of consider that? Are there various regulatory and clinical considerations for your path to market? Everybody really wants to know if you've kind of done the research and identified how do you get to market? How do you access your customers? And how do you actually make money on this downstream? So what's your revenue model once it's in the market? How should this technology be priced and with the competition and the total addressable market in mind? So if you have a very large market, you can be a little bit more forgiving on the price, but there might be a little bit more competition. So start to think about the different kind of variables in that impacts your pricing decision, especially competitors, because they've done a lot of that research already. And then the final one I had is protect the financials. So I'm not a big fan of financials. Unfortunately, you kind of have to be a fan of financials. A flawless story without a solid financial model will only get you so far. You just become a storyteller. So most investors, judges, and reviewers will look for something that's realistic, something that's scalable, something that's sustainable, and also creates value. So really consider both the revenues and the costs associated with building the business. You don't have to go too crazy. I remember I was back at my Proteus financial forecast, and it wasn't crazy built out, but it just focused really on the fundamentals, on getting to a certain point that would be expected within this certain technology, which varies based on the technology. So that's it. So I thought I'd end kind of cliche on a quote. So a pessimist sees the difficulty in every opportunity, and an optimist sees the opportunity with every difficulty. So you're going to have to see that with any of the technologies, any of the different strategies you're employing, your sales strategy, your marketing strategy, your customer experience strategy, your financial strategy. Everything will have some difficulty associated with it, but it will also have an opportunity. So it's a really cool opportunity to apply a lot of this stuff, learn from all the things that you're learning in school if you're at Western or any of the other universities, and be able to kind of apply something to something that's real, which is something that you don't often get a chance to do. So thank you. If you have any, I know this doesn't really have any room for questions or anything, but I've thrown my email here, as well as our websites. My LinkedIn's here as well. If you want to just quickly add me on LinkedIn, feel free. Always open to connect, and would love to kind of see who ends up taking on the win for this.
Awesome. Thank you so much, Chris. It's always a pleasure to have, past Proteus competitors back. And, as you were one of the winners of 2018. So it's really nice to see like the progression in your career. And, we're very happy that you're able to join us today and share your experience with us. Thank you.
Thank you for having me.
So this competition is structured as a 4-month-long journey for our competitors, where individuals are challenged to create a viable commercialization strategy for one of the 5 promising technologies showcased this year. Following the launch event, the contestants are asked to form their teams and submit their abstracts by January 9th. The selected teams will be invited to a virtual business plan workshop, and teams with the best business plans will be asked to participate in a live virtual pitch event that's scheduled to happen on March 29th for a chance to win $5,000 per technology. We're looking forward to the engagement that this will be bringing for the students with the community of competitors over the next 4 months. 5 technologies, 1 from each tech transfer office of our partnered institutions, have been selected to be considered by the contestants for this competition. We will be inviting the inventors of each technology to talk about their inventions over the next 25 minutes, and the attendees will have a chance to interact with inventors and ask questions at the breakout sessions after the presentations. So we really encourage you to circle through the breakout rooms and engage with each technology to kind of find, as Chris indicated, find that passion that you might have with one of the 5 technologies. Please note that when the winning teams will have the opportunity to help commercialize the technologies in collaboration with the respective TTOs if they're interested to do so. So that's another opportunity if you wanted to consider startups. Again, this competition provides you with that opportunity for further investigation if you are open to that. So with that, I think I would just move into Western technology. Please welcome Dr. Subrata Chakrabarti, Distinguished Professor at Pathology and Laboratory Medicine at Western University, who will be talking about his technology titled A Long Non-Coding RNA Panel as a Diagnostic Marker for Diabetic Retinopathy.
Dr. Chakrabarti, can you unmute yourself, please?
Okay, can you hear me?
We can hear you now. Thank you
Can you
very
see
much.
the screen?
Yes.
We can see your slides.
Okay, awesome. That's a fantastic achievement for me if I don't get anything. So we'll talk about diabetes. I'm a clinician scientist. I'm a pathologist. So I do disease diagnosis for a living. Now, I think everybody knows about diabetes. So in 2015, it was projected that 1 in 10 adults in 2040 will be diabetic. You know, we're proud to have achieved that goal already in 2021. So today in the worldwide, there is 1 in 10 people in diabetes. So why it's important? It is important due to the way diabetes affects tissue. And we are going to talk about one technology which is related to diabetic eye disease or diabetic retinopathy. So between 80 to 100% of diabetics will develop this disease. Now, just to give you an idea, if this is your normal vision, an advanced diabetic retinopathy, you will see same scene like this. So what's happening? There are some current therapy. Over the last 20 years, it's developed, but there is some adverse effect. There is frequent eye injection, and some of people don't respond. And on the second part where I'll focus is there is no blood test. So if you want to get diabetic retinopathy diagnosed, you have to go to an ophthalmologist. In London, there is a waiting period of 6 months. And just imagine what is the waiting period in a worldwide basis and availability of sophisticated technology to diagnose this disease. So we need quick and correct tests. And we use something called long non-coding RNA for this purpose. Now, if we look at our genome, if this is the size of genome, this part is translated into RNA and protein is produced just this 3%. And all our treatment and diagnostic is based on that 3%. We have over the years ignored the rest 97%. And this project focuses on something. And there are several types of this transcriptome. We focused on one called long non-coding RNA. And we used it for both diagnosis and treatment. And we'll focus on diagnosis and touch the treatment a little bit. So the way this will work, we have developed this assay, we have studied this, and we have scientifically validated it. So a family physician or an endocrinologist sees the patient, takes the blood, comes to the lab, we extract RNA, and in a plate, we have immobilized multiple different primers, multiple issues. It goes in a PCR. And then we can, based on this data, we can risk strategize it. We can say patient A need to go and see an ophthalmologist. Now patient B can wait for a month or wait for a year or so. So this is an RT-PCR panel. Simultaneously, we looked at 9 of them, and we have already, in our first attempt, we have looked at 80 patients and the science has been published. A PCT is under review, and now we have initiated a larger study where we plan to look at 500 patients. So what we have developed a PCR-based test for serum, and this panel can be used for diagnostic screening tool. and prognostic assessment. This is a disruptive technology with a worldwide appeal. And your policymakers will be really interested in this screening test. In parallel, we have one of these long non-coding RNA we are also developing for treatment, and we have done preclinical studies. We found this is non-toxic and stable, and it can prevent a lot of things about diabetic retinopathy. So overall, this long non-coding RNA-based diagnosis and treatment could be a game changer. So bringing back, this is a little bit old, but market size of diabetic population worldwide today is close to 540 millions, and 9% of global healthcare dollar is consumed. So current diagnostic tool, as we say, it's difficult. And this technology will lead to good diagnosis, good treatment, and screening, with saving a lot of healthcare dollar. Competition-wise, there is no RNA-based treatment in the market for diabetes or any disease. And they have started coming out in some disease, and no RNA biomarker available. So that's our pitch. We'll love to get your input and your thoughts. And we did it in partnership with World Discoveries, and Saqib, he's one of our really driver of our business side. And I'll stop there. Thank you.
Thank you very much, Dr. Chakrabarty. We now will move to, can I please welcome Dr. Abdullah Al-Sayed, Professor of Mechanical Engineering from University of Guelph, who will be talking about his technology titled High Strength, High Conductivity Aluminum Alloy. Welcome.
Hi there, hello. I'm just trying to get my screen to start sharing. Are you able to see it now?
Yep.
Okay, thank you very much. Thank you for the introduction. So my name is Abdullah Al-Sayed. I'm an associate professor at the University of Guelph. So I'll be talking about a castable aluminum alloy with high thermal conductivity and high electrical conductivity. So this invention was to meet demands of next generation mobility, as well as some other sectors. But this example I have shown is an example showing a battery tray for the Ford F-150 Lightning. So this is Ford's electric variation of its popular pickup truck. And then this new F-150 Lightning, its electric pickup truck, is 1,600 pounds heavier than the Ford F-150 gasoline version. And part of this extra weight comes from the very high amount of batteries that are used to propel the vehicle. So for electric vehicles and hybrid vehicles, we must reduce the weight of these vehicles to increase efficiency and also enable greater range for these vehicles. And one way to do this is the use of light metals such as aluminum. They are light and durable and easy to manufacture. And so we want to incorporate them a little bit more into our vehicle bodies in order to reduce the overall weight and increase the overall range of electric and hybrid vehicles. So this graph is showing, this is the only graph I have in my slides. I promise no more other ones after this one. But what this is showing is a new castable high conductivity aluminum alloy we call HCA. And this plot on the y-axis is showing electrical conductivity as well as hardness, which can be related to strength. And on the far left, we see a very small blue bar, and that's the hardness or strength of pure aluminum, while the yellow dot at the top is the electrical conductivity of pure aluminum. So pure aluminum is a very, very good electrical and thermal conductor, but it's very, very soft and weak. And so we can't really use it for many usable products. On the very far right, the big blue graph, that shows a typical cast aluminum alloy. It has quite a significant strength and hardness, but its electrical conductivity and thermal conductivity tends to be quite low. So they're not very good at dissipating heat or moving electrical charges around effectively. And we really need this for a hybrid or electric vehicle. So in the middle two are two variations of what we call our high conductivity aluminum alloy. And what this alloy does is it meets a little bit of a demand in between the pure aluminum and most cast aluminum alloys, where it has reasonable or quite high electrical and thermal conductivity, as well as reasonable strength. So it's very advantageous for emerging applications in EVs, hybrid vehicles, renewable energy, as well as consumer electronics. So here's another depiction of the performance of this HCA alloy versus a traditional cast alloy. So we have two identical pieces of this alloy, as well as similar size ice cubes sitting on top. And we're seeing how they're melting as it's being heated from the bottom. And so you can see the HCA alloy is better able to transfer heat through its body itself in order to melt the ice on top of it. So where we see potential applications, well, very significant ones in EVs and other hybrid vehicles. For example, components such as electric vehicle battery trays, electric motor casings, and heat sinks. These are currently made with traditional aluminum cast alloys that don't have that high electrical and thermal conductivity. If we were to replace them with this HCA alloy, for example, we're able to better manage heat, better manage electrical charges, and so we could better regulate the temperatures of the batteries that we use, increase their performance, increase their efficiency to get a more sustainable electric vehicle design, as well as one that enables a higher range. Other areas where this could be used is renewable energy. For example, in wind turbines, you're taking the wind energy and you're running it through a generator. And so if you have heat losses or electrical charges losses, if you're able to capture those, you're better able to harness energy from the wind you're trying to collect. As well as consumer electronics, your cell phones and laptops. These have very tight spaces and a lot of electrical components in a very tight area, which generates a lot of heat and stray electrical charges. So if we're able to maintain them and transfer them effectively throughout the structure in order to improve efficiency and reduce heat, you're using less battery power and to actually run the laptop so you can run it for a longer time, as well as reduce the size of heat transfer components such as heat sinks. So this invention has alloy with high electrical conductivity, high thermal conductivity, and a good reasonable strength that acts as an intermediate between cast and wrought aluminum alloys. So thank you very much for your attention. My email is there. If you have any further questions, then I'll be there in the breakout rooms afterwards to answer any further questions.
Thank you very much. So I think the next, our next inventor is Dr. Philip Brits McBin from McMaster's Chemistry Department, who will be speaking about their technology titled Novel High Throughput Method for Vitamin D Screening.
Okay. Hello, everyone. Can you see my slide?
Yep. Yeah.
Okay, perfect.
Welcome.
So yeah, thank you for the introduction. So it's my pleasure to introduce you to some new technology that we developed to address, I think, a global health issue, the prevalence of vitamin D deficiency. Tragically, vitamin D deficiency is underdiagnosed, underprescribed, and undertreated. So the main idea for our approach is to develop a high throughput, cost-effective method for routine testing. Now, this is relevant because vitamin D is no longer only a mere vitamin, but is a prohormone that's associated with many sort of chronic disease risk, including chronic pain, depression, and immune dysfunction. So as I mentioned, vitamin D has pleiotropic effects. It activates more than 3,000 genes. So it's no ordinary sort of vitamin. It's largely derived from UV exposure, from sunlight exposure. Unfortunately, sun exposure as we enter the winter months here in Canada is lacking in many cases. It's a lot of risk factors for vitamin D deficiency, as shown on the right side, in terms of seasonality, as we mentioned, ethnicity, older age, and females generally have more risk for deficiency, obesity, poor diet. So many factors can contribute to that. Otherwise, with low light exposure, typically your vitamin D is derived primarily from fortified foods such as milk and other dietary components and other supplements. So the main vitamin D species that is measured to assess vitamin D status is the circulating form of vitamin D, referred to as 25-hydroxyvitamin D, or casfadiol. However, the active hormone, in fact, is the dihydroxyvitamin D. So severe deficiency has historically been associated with nutritional rickets, bone malformation. What's really not well recognized is there's a high prevalence of insufficiency, suboptimal levels of vitamin D that are related to a wide array, again, of health problems, cardiac-related, neurological, and as I mentioned, immune system dysfunction, especially respiratory infection susceptibility. So this is obviously really relevant as we have encountered now 2.5 years of COVID-19, and how can we actually improve health on a personalized level? So current methods for vitamin D status determination, this kind of reflects why it's not widely measured on a population level, either based on an immunoassay, a chemiluminescence-based immunoassay that's convenient to use, it's relatively cost-effective, but generally it suffers from poor selectivity. It's prone to cross-reactivity, so it leads to, again, inaccuracies, as well as batch effects with continuous use. The gold standard method is based on a technique called liquid chromatography tandem mass spectrometry. It's an instrumental-based method of analysis. Generally has much greater selectivity, although it's slower and more costly to perform. So often it's not done routinely for large-scale analysis. So our technology is trying to bridge the best of both worlds. Could we actually develop a method that has high throughput, it's low cost, but is accurate and selective? So this approach is referred to as direct infusion tandem mass spectrometry, and we developed a new reagent called nitrosopyridine. So in this case, our data workflow involves processing a blood sample, such as plasma or serum. We extract it, we perform the chemical labeling, derivatization, which is critical for improving sensitivity, do a sample cleanup, and the method here basically avoids any separation. So we can flush through the analysis, do a direct analysis within a duty cycle of about 3 minutes. This just shows you a concentration profile. You can see we get a concentration-dependent enhancement in signal as a function of 25-hydroxyvitamin D3 levels itself. So we can quantify it with a high degree of accuracy. We can perform the analysis continuously over a 24-hour operation. So we can process 400 samples, say in this case, over a 24-hour period for continuous analysis with high precision, as you can see by this control chart itself. So overall, the advantages of this method, it's faster, less costly than the gold standard method, LC tandem mass spec, and it has very good mutual agreement with that method. And compared to immunoassays that are currently widely used, it's more precise and more robust and more reliable at the same time. So we performed actually a clinical trial pilot study involving pediatric ICU patients who are prone to vitamin D deficiency and prone to infections during hospitalization. In this case, these Melton plots just show on the left side a two-way comparison between the LC method and our method. So there's a minor degree of bias in this case, but if you can compare that with the immunoassay, there's a more than a twofold increase overestimation of vitamin D status. This is important for that population of 30 children that we tested for. If we used immunoassay for screening initially, you can see that we will underestimate the true prevalence of vitamin D deficiency, almost by, again, a significant factor in this case. So more than threefold difference. This leads to undertreatment of vulnerable children. So it really matters to have not only a fast, cost-effective method, but something that's accurate. So our current status right now, the method, we've published a method in the journal Lipid Research. We've submitted and filed a provisional US patent, and we're considering license opportunities, developing kits with current manufacturers, or even considering a startup company given our interest in personalized health and wellness. And I think this idea of immune health, given, again, what we've been through in the past 2.5 years, how can we empower individuals to take care of their own health? Again, vitamin D is just one, but very important sort of marker of metabolic health and immune status. We've had some media attention regarding this method because of our involvement with an ongoing multi-center clinical trial. So looking at vitamin D, high-dose vitamin D intervention, but only for those that require it who are deficient. So it's a very selective, sort of precise approach for interventions. And our envisionment of approach is, can we actually do sampling? So without going to the phlebotomist, right? That often is prevents people from being involved with their health. Can we actually provide a home testing kit that allows for a routine sampling of blood that's precise and accurate? We can mail it, And we can provide not only like a diagnosis, it's not a diagnosis per se, but an assessment of one's baseline levels. Many people actually partake with supplementation, but they have no idea whether it actually makes a difference or not, and whether they're in the optimal range for immune health. And this is the critical sort of facet of our work. So with that, I thank you for your attention, and I'd be happy to speak with interested students.
Thank you very much. So the next technology is from University of Windsor. And I'd like to invite Dr. Tricia Breen Carmichael, professor at Department of Chemistry and Biochemistry at University of Windsor, who will be speaking about her technology, tuft pile fabric as framework for stretchable and wearable composite electrodes.
Okay. Can you hear me and see my screen?
Yep.
Okay, great. Okay, so I'm really happy to be here. This is my first experience with this competition. So our research is in the area of wearable electronics. Specifically, what I'm going to talk about today is the idea of electronics integrated into fabrics, so in our clothing. So I just want to start with kind of this vision for the future. Where are wearable electronics going? We're all familiar with wearables like, you know, you've got an Apple Watch or something like that. But where we're headed are wearables that are more comfortable and more suitable for the human body. So soft materials, soft, functionality that is seamlessly integrated with the human body. So sort of hidden and integrated electronics and clothing. So these, devices of the future, or, near future, hopefully will have an aesthetic. They'll be convenient to wear, and they'll be functional in the sense that they can sense information. This could be biological information about the person wearing it, display information and transmit information, and so on. And so my group has been working in this area for some time, and this is actually one of our journal covers for one of our papers, not the invention I'm talking about today, but just to give you an idea of how much broad appeal this area has. We had a lot of media attention for this particular work. It went to a lot of media outlets. And so as an academic, when your work is being talked about on mining.com or Lithium News and fashion websites, there's a hunger for these kinds of exciting wearables. And so I just want to show briefly that this is the work that was in that publication. So you get an idea of what laboratory devices look like. So these are wearable, they're soft, they're stretchable, they're made from fabrics, they conform to the human body, and you can wash them, right? So we can put these in underwater. And so it's very exciting, and you can think of lots of things to do with this. But the really difficult part is how to power them. So in the lab, of course, we have a power supply that sits on the bench. But to have a real wearable system or a real wearable device, we need to have a power source. So we need batteries. And today's wearable batteries are really, unsatisfying. When we think about, these kinds of like pouches that you wear on your waist or on your arm, or this, whatever this is, these are not compelling. You can have the coolest wearable in the world, but if you have a black box strapped to your back, it's not that fun to wear. So, we wanted to work on this problem of energy storage using in textiles to sort of distribute that in the textile itself. And so lithium-ion batteries are a great solution. We use lithium-ion batteries for everything. They're around us everywhere in all of our devices, our phones, our electric vehicles. And to integrate them into textiles, the difficulty is textiles are clothing. These are stretchable, soft things. And the materials, the electroactive materials in batteries are brittle and hard. And they need to be protected from strain, meaning they can't really be deformed or they'll crack. So our invention is we became inspired by velour fabric, right? Everybody's familiar with this fabric. It's very soft. And the structure of velour fabric looks like this. It's got this knitted back plane and then these cut piles that sort of protrude out from the knitted background. So this part will stretch, and then we have these sort of tufts, and that's what makes velour nice and soft. And you can see that's what it looks like from the top in the picture below. The reason we chose this is because when you stretch this fabric, these cut piles don't experience any of that stretching. All of the stretching is concentrated in this back knitted back plane. And so what we can do is we can put the electroactive material just on the cut piles, coat selectively here, and also integrate the electrode material for the lithium-ion battery, which is a metal, on selectively on the back plane. And then when you stretch that, these cut piles with our brittle active material are not experiencing any strain. They just ride along with the fabric at their where they're looped into the fabric, where they're anchored down. And so this is basically a strain protection architecture for brittle materials. And so one other thing I wanted to note about this is we use commercially available fabrics and also chemicals and solutions. So there's nothing, everything is accessible. This is also an all solution-based process to do the fabrication. It uses established technologies. So we start with velour fabric, and I'm not going to go through all these steps, but all of the solutions we use to deposit metals, that we need to make this battery electrode, they're all very established. They come from printed circuit board technology, so commercially available systems. And because it's all done in solution, it's scalable. You just need a bigger vessel. And again, the brittle electroactive material, which you can see here in blue, is protected from strain, so it doesn't crack. So this kind of feeds into this vision for wearable electronics, where we have different electronic systems integrated into our clothing in a way that's unobtrusive, including this battery source. So I think the challenge is really like, how do you put these pieces together to make something that someone's going to want to wear? I think that's it for me. I would just like to point out my co-inventor, Dr. Wenwen Wu, who was absolutely instrumental in making this invention, and she's now a postdoc at Northwestern. Thank you for listening, and I'll be happy to chat in the breakout room.
Thank you very much. This brings us to our last technology. That's from University of Waterloo. May I welcome Dr. Juwen Liu, Professor of Chemistry at University of Waterloo, who will be telling us about DNA aptamer biosensors for lactate detection.
Okay, can you see my screen?
Yep. Yeah.
All right. Thank you very much for the introduction and the opportunity to present. So lactate is a very important biomarker. Under normal conditions, glucose is converted to CO2 and generates a lot of ATP molecules for energy. But when the oxygen level is low, lactate is produced. So athletes are very keen to know the lactate concentration in blood. And actually, lactate is a biomarker for all the conditions when you have oxygen deficiency. That includes sepsis, infection, heart attack, and a lot of lactate in blood would lower the blood pH that can cause lactate acidosis, which is a very life-threatening condition. In addition, there are also many other cases where people want to measure lactate outside the body. So that's mostly in the food industry, for example, to look for dairy products, brewing and distilling, and in the wine industry, when you have a lot of lactate, that's an indication of bacterial growth, and it will affect the taste of the wine. The other research purpose, people want to measure lactate concentrations. So currently, lactate is measured by electrochemistry for the most part. So we can look at an example for measuring glucose. It's essentially the same technology. So this shows the very first generation of electrochemical glucose sensor. You have a platinum electrode, and then the key reagent is an enzyme immobilized on the electrode. So over the years, the electrode has been now much smaller, screen printed, and much cheaper. And currently the trend is go to continuous glucose monitoring, but it's all based on the same chemistry of immobilized enzymes. So the enzyme for glucose is called glucose oxidase. It produces hydrogen peroxide, and that's actually the molecule being detected. So for lactate detection, you replace the enzyme by lactate oxidase or lactate dehydrogenase. So both enzymes can react with lactate and produce some byproducts, including hydrogen peroxide or NADH. So those are the molecules that can help the detection. So the first steps we are interested in is to do it without touching the body, and that will be easier. So we're interested in looking for lactate detection in wine, in food products. So if you look into the market, there's actually a lot of lactate test kits available commercially. They are all sold at about $1,000 per kit. That's usually good for about 50 to 100 tests. So this is one of them, and you can see it contains 8 bottles of reagents from a company called Megazyme. So the chemistry is using lactate dehydrogenase that produce pyruvate, and then pyruvate reacts with glutamate in the presence of another enzyme that can produce a colored product. So that's a 2-step chemistry with a lot of reagents involved, and it really involves like 6 test tubes and multiple steps. Takes a very experienced researcher probably an hour or more to complete the assay. So I think there's a lot of room for improvement. The technology we're going to use relies on DNA aptamer. So this is just a piece of DNA molecule that can bind to lactate specifically. So we generated this sequence in our lab, and that's the reagent we're going to use. So we use the method of fluorescence for the detection. We can label a fluorophore on the aptamer and then hybridize it with a quencher labeled complementary strand. So initially the fluorescence is low. When we add lactate, the aptamer can bind, and then that will release the quencher labeled strand. The fluorescence will show up. So you can see here, at this point we add lactate, you get immediate fluorescence enhancement, and the more lactate you add, the higher fluorescence enhancement you get. The sensor can detect up to about 20 millimolar lactate. So this is a very physiologically relevant range for lactate measurement. And the sensor can also tell the difference between air lactate and D-lactate. So in the body of human beings, we have mostly air lactate, and the D-lactate is very, very low in concentration, but we can still differentiate between these two very similar molecules. And we also compare the other molecules that may present in the blood with structures similar to lactate. So most response we saw was from the D-lactate, and then pyruvate has almost no response, and the 3-hydroxybutyrate, which differs from lactate only by a methylene group, also has no response. So it's very selective for lactate molecules. So currently, we filed a provisional patent to protect the sequence, and a paper has been submitted for publication that is currently under review. So our goal is to replace lactate test kits like this in the market, because I believe our technology has a higher reagent stability, lower reagent cost, and much simpler operations. So future, right? We hope to dream bigger, to continuously monitor both lactate and glucose using aptamers in blood. Thank you.
Thank you very much. I'd like to thank all our inventors for telling us about their exciting research with the potential of becoming future products that are solutions to real problems. We're looking forward to the creativity that will be sparked by competing teams in the coming months. At this point, I'd like to invite Dr. David Muir, Western University's Associate Vice President of Innovation and Strategic Partnerships, for closing remarks.
Suzanne, thank you so much. And it's an honor to be asked to say a few words in closing of this part of the session. Wow, those were some pretty awesome, incredible, exciting, and diverse technologies. I think that's a good slate of technologies to start the competition from. This really is a fantastic opportunity. I wish this existed when I was a student. And to echo some of the things that Chris had said, the opportunity to step a little outside of your formal education and learn about IP, about business case preparation, and have the opportunity to practice some pitches, I think is an invaluable experience for you. So I'd really encourage you to be involved in the program. I'd encourage you to branch out and work with other universities, to take the opportunity to work with the Tech Transfer Office and the business development people to learn skills in business and in pitch making. I think is really a phenomenal opportunity for you. I wish you all the best in this. I look forward to 4 or 5 months out when we see the final presentations. A big thank you, Suzanne, to you, to Rebecca, to Jordan for hosting and organizing this, and to the World Discoveries team, to our inventors, to our partner institutions, and to Christina and Tech Alliance for their continued support of the program. Thank you all, and all the best.
Thank you so much. Thank you. So this brings us to the end of our formal part of the event. We are going to be shortly going into the breakout rooms, but before we do that, I just want to again echo Dave's comments and thank our partners and sponsors and speakers for coming out today. Please note that this breakout rooms will be open for about 25 minutes, and then we will reconvene back into the main room before we say goodbye. So within that, I think now as we are going to break out into our breakout rooms, you should be able to unmute yourself to ask questions, and you will also have the possibility of going from breakout room to breakout room. So I really encourage you to visit all the technologies, because you'll have access to the inventors and the business development managers who are supporting the technologies. So it will be a great opportunity for you to connect and ask questions and find your passion for one of the projects. So with that, I think we are going to be, the breakout rooms are going to start.
Yeah, so the breakout rooms are now open. So if you want to click the breakout rooms item, you can just click the breakout room for the technology that you want to go to.
So I think Subrata, like you have to go to your breakout room, correct? Do you
Yeah,
know
I'm
which-
just going to, I'll move you there, Subrata. Oh, are you going there? Yeah, I think, yeah.
I think of it, okay.
And if anyone needs assistance in getting into your breakout room, just let us know in the chat, or you should now be able to use your mics. Does anyone in the main room need help accessing the breakout rooms?
Hello.
Hello?
Hi. This is not about the breakout rooms. This is just about the competition in general. I was wondering who I could ask a question to.
For what? In regard to what?
In regard to like the pitch, this is a very like science heavy like topic, and I was just wondering like when we do like make like our pitch, how like are we trying to like pitch it to people that already know the science behind it, or are we just like pretending like they have no idea and like it's kind of like more like a basic like if that makes sense. And
So
that's
you-
really
So
worried.
you would have to really like lay out the problem, what's the problem, and then what the solution is. So you have to, but it's going to be more within a business sense. So you're not going to go into a whole lot of detail on the scientific aspects of the technology, but you have to provide enough information to basically convince your audience that you understand the technology and you have a business plan that matches, you know, the opportunity that technology is bringing. But there will be workshops for that. So
Right.
like we actually have workshops, so you can actually like there will be the instructions given to that, and you can actually, and you can work with your business development managers as well to refine that pitch.
Okay, perfect. Thank you very much.
No problem.
Are there any other questions we can help answer about the competition? And again, if you need help moving to one of the breakout rooms where you can ask more about the technology, just add it in the chat and we can move you to the breakout room.
Yeah, because you should be in the breakout rooms. This room is actually not as exciting as the breakout rooms are.
Yeah, just to repeat, you look in your menu at the bottom, click on breakout rooms, and the different choices will pop up and you'll be able to scroll up and down and join. If you can't see that, let us know and we'll help you out.